7.3 in Advanced Algebra 2. Today we talk about the logarithm. What the logarithm is he is the inverse of an exponential function. We have a graph right here. This blue thing is our normal exponential growth. It's got that cool point of 0, 1 right there. That's going up from left to right, so that's our exponential growth. And then, does this blue thing have an asymptote at all? Yes or no? Does exponential growth have an asymptote? What kind of asymptote? Horizontal, vertical, or oblique asymptote? It's got a horizontal asymptote right here at y equals 0, normally, correct? Well, remember our talk about inverses. An inverse is a reflection over the line y equals x. Remember, like when we made a table of values over here, if they're truly inverses of each other, don't you just switch x and y around? Do you see how they did that in the table? All the x's and y's are switched around. Cool. So this red thing is the logarithm graph. He is the reflection of the blue thing over the line y equals x. And since the blue guy had a horizontal asymptote at y equals 0, 2 over the line y equals x. What do you think? Do those reflect to each other over the line y equals x? Right? This is an asymptote for this logarithm guy. What kind of line is it, though? Vertical. Isn't this at x equals 0, correct? Think about it. If the asymptote for the exponential growth equals 0, and we're switching x and y around, well, wouldn't this switch to an x instead, right? So it's got a vertical asymptote at x equals 0. Here's the phrase that I asked you guys to write down, so if you're in video land and you haven't written that down yet, logarithm, base, argument equals exponent, and base to an exponent equals the argument. This is what you're pretty familiar with. You probably don't know the word argument. You know, it's like, what do you mean, like the argument? It's like the answer to your solution. It's the argument. Like, this is the answer that we got, okay? So here's a physical example. 3 to the y equals 27. The things you should be able to recognize is the base and the exponent, correct? Aren't you pretty familiar with that? What's the base out of this situation? 3 is the base. Isn't the exponent the y, right? It's like the answer that you got, right? That's the argument, okay? It's called the argument. Well, when you have y equals 2 to the x, isn't this an exponential situation, right? Because the x is up in the exponent. And we want its inverse. We switch x and y around. So do you see how they switched x and y around in this part right here? Well, we don't like equations solved for x. We want to solve them for y. And they had a problem when they wanted to solve for a variable that was up in the exponent. You know, it's like we could rewrite them at the same base if possible, but this not possible. So they invented the logarithm, which is really what this is. This is the inverse of it. What was the base in this situation? 3. You see where the base is located right here? Isn't 3 still the base? Cool. What was the exponent in this situation? Y. Do you see where the exponent is located? That's over here now, correct? And the argument was 27. This is read out loud. Log base 3 of 27 is y. The log base 3, the logarithm, you know, we just call it a log, right? Log base 3 of 27 equals y. So here's what they're asking us to do. Here I have it a little bit more abbreviated. I abbreviated argument and exponent. Think about it like this. The base, by the time we're done today, you'll realize the base is down here. Logs are expensive. It's like logs are expensive. Like if you want to go buy a log, you know, logs are expensive, right? Log, argument, exponent. Cool? Logs are expensive. That's how Pirate says it. You know? It's like logs are expensive. Arg. Get it? Logs are expensive. So it says use the definition of logarithms. That's these two things right here. There are definitions of logarithms to express the logs in exponential form. So you see on number 1 that they gave us a logarithm. How do I know it's a logarithm? That's a logarithm right there. You all cool with that? They want us to write it in exponential form, so that's this guy right here. All I need to do is turn it into base to the exponent equals the argument. Out of the 2, the 8, or the 3, which one's the base? 2. So I'm going to make it look like this. Which one's the exponent now, the 8 or the 3? Logs are expensive, right? Which one's the exponent? 3 is the exponent, and that should equal the argument. Now, you look at that. True or false? Is 2 to the third 8? Every one of these has to be true, right? This is an equation to start with. All we're doing is just rewriting it in exponential form. There's two forms. Logarithmic form, you know it's in logarithmic form because it's got the log in it, and exponential form. So let's try that again on number 2. It's in logarithmic form. Let's write it in exponential form. The base is what? 3 to what exponent? And that should equal 729. And if you punch that in your calculator, I'll bet you it does. 3 to the 6 equals, didn't we get 729 in that situation? Cool. 3, what's the base? 4 to what exponent? 2 equals our argument, which is what? A piece of cake, right? Just taking a logarithm and rewriting it as an exponential form. Give 4 a shot. What to the what equals what? What? Base, exponent equals argument. What do we got? 3 to the second equals, now let's just pretend that I made a mistake. What if I said 3 to the 9th equals 2? Can you realize that's incorrect? It's like there's no way that 3 to the 9th power equals 2. Do a mental check. It's like, does that seem right? You know, yeah, 3 squared is 9, right? So, cool. How about this one? What's our base in number 5? 4 to what exponent? Negative 4th. That should equal 1 over 256. Well, I'm not even going to really type it in correctly, but you see the negative exponent means you're going to get a reciprocated answer. It's already a fraction, correct? Is 4 to the 4th 256? Yeah, so that looks good to me also. Try 6. Ten to the what? Negative 2 equals 1 over 100. Let's slow down for a second. You'll probably not see this written this way in the future. This is called the common log right here. And when the base is 10, do you guys know about the metric system? Metric system? Heard of it before? What is the metric system designed around? What number? Like you can't have fractions in the metric system, right? It's all decimals. And what are all the decimals about? They're in what base? 10, right? Aren't they always in powers of 10? So you'll really see it written like this in the future. Just like this. You don't see this anymore, do you? Don't you just see an X instead of putting the 1 in front of it? This is like elementary school right here, and now we're advanced. If there's no base written right here, it's assumed to be base 10 because that is the common logarithm. If they don't put a number right there, there's a 10 there. You with me on that? So base 10. Cool. Like I said, they put it just because we're very new to it. Now let's go the other way around. This is the harder of the two things to do. It's not that hard. It's just the harder of the two things to do. What form is this in right now? There's two forms today, logarithmic or exponential. What form is this in? Exponential. They want us to write it in logarithmic. It starts with the log. Then you need the little base as a subscript. Well, what's the base? 4 is the base. What comes next? Logs blank expensive. What comes next? The argument. What's the argument? And people are like, how do you know that that's the argument? Well, you should know two things for sure. You should know what the base is, and you should know what the exponent is. Aren't those familiar to you, correct? The thing that's up there that you're not sure about is that 64, he's the argument. So log base 4 of 64 equals 3. Y'all cool with that? How about this guy? We want him logarithmic, so log base 5 of 125 equals 3. Okay. Next one. Log base what? 15 of the argument, which is 3375, equals 3. One more here. Log base 27 of the argument, which is equals 1, 1/3. 2 more. Hopefully you're feeling this is pretty simple. These phrases will help you out. We're just setting you up for how to use them later, like how to go back and forth. Once we start solving logarithmic equations and this, that, the other, that's where these skills come in handy, how to rewrite it as exponential or rewrite it as logarithmic. So just crawling before we can walk kind of stuff. Sound cool? Check this out. Evaluating a logarithmic expression. They're asking us, hey dude, what's log base 16 of 4? Like, what is it? Like, what is log base 16 of 4? It'd be great if you could punch that in your calculator. Do you all see that you have a log button over here? Right? Here's the problem. That's log base 10. This button only works for logs base 10. According to this problem, is this a log base 10er? Plus, these will be our non-calculator type questions on our test. It's split into 2 parts, calculator, non-calculator. Every single one of these should be done without a calculator, okay? So here's how we'll start to learn how to do these. We want to know what this is. Question for you. Do you know what it is? Just say no. Do you know what it is? No. So let's make something up for what it is. Doesn't that right there say is, if you say that out loud? This is, boy, I don't know, I'll call it x, right? The instructions say, why don't you just turn them into an equation first, right? Just, I want to know what log base 16 of 4 is. So, since I have it in this form, let's turn it into exponential form now. What's the base? 16 to the exponent. What's the exponent? X equals 4. And now you have the mental skills to say, 16 to what power would give 4? What do you think about that? Isn't the square root of 16 turn out to be 4, right? So how do you do square root to what power would you really have? X equals what? 1/2, baby. We'll get better. Like I said, that was a tough one. Isn't 16 to the 1/2 power turn out to be 4, right? So now let's answer the question. They asked you what the log base 16 of 4 was. Here it is. Log base 16 of 4 does equal 1/2. You cool with that? And that's our answer. Hey man, what's the log base 16 of 4? Oh, that's 1/2. Right? These two are the exact same thing. 1/2 is the same thing as log base 16 of 4. Next one, make it equal to x first. Okay? Now rewrite it as exponential. What's the base? 3 to the x equals 243. So 3 to what power equals 243, my friends? X equals 5. Right? That's our perfect note card again coming back to us. Right? It's just like, oh, missing the weird part. Now rewrite it. Log base 3 of 243 is 5. Cool with that? Next guy. I don't care if you can get to the answer right away or not. We're not doing it that way today. You will rewrite it with an equation and equals x. Then you will rewrite it as exponential. Then you will solve for x. Sound cool? So they want to know what this is. Call it x. I don't know what it is. Rewrite it for me. Chelsea, what would it be? I don't want any logs because I want to write it 3x to 81. There you go. Maybe. I'll write what you said this time. Hey, that's awesome. 3 to the x equals 81, right? So now answer the question. This is just mental. 3 to what power equals 81, my friends? So x equals 4. It's more than any time you've got it all written out, you probably already know what the answer is supposed to be. So set it equal to x first. Then rewrite it exponentially. Base to the exponent equals argument. Put the 1/2 in parentheses, since that's the base. to write it correctly. You all good with that? Just rewritten exponentially? Now I see the base is a fraction, and then it came out to be a non-fraction. Tell me what that means about the exponent right there. It's going to be a negative exponent. But just think of it as 2 to what power equals 256. Take a guess, because that's not on our note card. 2 times itself, how many times in a row would give you 256? Do you know what 2 to the 5th is? 2 to the 5th is 32. What's 2 to the 6th? It's going to be times 2 again, which is 64. What's 2 to the 7th? 64 times 2. 128. Then 2 to the 8th would be 128 times 2, which is how much? So what's x equal? 8. Is it 8? It's got to be negative 8. How come it's got to be negative 8? Because of the reciprocating of the old base right there. Log base 1/2 of 256 is really a negative 8. Sweet? Let's try 17. Rewrite it first. 100 to the x equals 100,000. Woo! Ouch! What's 100 times 100? How many zeros would you have? 100 times 100. 4 zeros. 1, 2, 3, 4, 5. Ooh, is that our answer? Is it 100 squared? Nope. If you took 100 to the 3rd power, right, you'd get how many zeros then? 6 zeros, right? Nah, that's 5 zeros. That just tells me right there it's between 2 and 3, right? It's got to be between 2 and 3. Boy, there's got to be a better way to figure this out. I gave you 2 problems on your homework quiz today that you just attacked like a champion. The first 2. What did you do on those 2 problems? Rewrite them with the same base. A wild guess what base you could rewrite both of these as. Base 10. What is 100 rewritten as base 10? 10 to what power? 10 to the 2nd. And it's still to the x, right? And how about this guy? Oh, how many zeros does it have? So that's really 10 to what power? To the 5th. See how I rewrote both of those as base 10. And now, of course, we have to do power to a power. This is really 10 to the 2x equals 10 to the 5th, right? Now that they have the same base, 2x equals 5. So x equals what? And that's really 2.5. Isn't that between 2 and 3? Like I already mentally figured out, it's got to be between 2 and 3. So there we go. 2. Over here, give 18 a try. Barack Obama, give it a try. What? What? Oh, yeah, thanks. Log base 100 of 100,000 equals 5/2. Thanks, my bad. I got too excited there. What I need us to get better at is our powers of 2, right? You know, we don't have like perfect 7ths, perfect 8ths, perfect 9ths on our note card. The powers of 2 can be expected to be known because you have all the way up to 2 to the 5th, which is 32. When you do another power of 2, doesn't power of 2 mean you're doubling it, right? So 2 to the 6th would be 32 times 2, which is 64. Then what would 2 to the 7th be? It'd be 64 times 2, which is 128. So what's x equal? It's got to be a negative number because of the reciprocating that went on there. Cool. Remember, these are expected on the non-calculator test. Log base 2 of 128 equals -7. Dog. Get them both done. If you need to rewrite them as the same base, you might have to rewrite them as the same base. Pause the video, give them a shot. Now before we move on, I want to set you up for how we'll use this for the rest of the chapter. This means, guys, if you was to ever see something like a log base 4 of 64, what could you put in its place instead? What is log base 4 of 64? It's really a 3, right? Aren't those the same number, right? Because this number right here, this argument, isn't he a power of 4 in the first place, right? So it's like, hey, when I give you this scrambled junk of weird stuff like log base 5 of 265, you could really substitute 4 in its place instead, because those are the same number right there. You with me on that? All right. Story time. Richter scale. It's the most popular logarithmic scale around. Richter scale measures earthquakes, something we don't have that many of around here. But like they measure it logarithmically. Powers of 10. What's the common log's base? What's common log's base? Base 10. Any logarithmic scale is in base 10. So earthquake intensity, that's why each number between them is 10 times as much. So if the earthquake measured a 1 on a Richter scale, or if it measured a 2, this guy is 10 times more powerful, because isn't that an entire unit? Every unit is a power of 10. If you measured a 3 on the Richter scale, this is 100 times more powerful, because that's a difference of 2, and that's 10 squared, which is 100, right? So the bigger the number of the earthquake, it's very, 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 very powerful, okay? The largest recorded earthquake in the United... Oh, I guess we got to finish reading this. The intensity of an earthquake can be modeled by this equation right here. Notice that is an exponential equation, because where is the variable x located? In the exponent. And you see there's no logs in it whatsoever, right? That's an exponential equation, where x is the Richter scale rating. The largest recorded earthquake in the U.S. history was a magnitude 9.2 that struck Prince William Sound, Alaska on that date. What is the intensity of that earthquake? This is the magnitude, correct? That goes in for x. Correctamundo? Just that simple. Because that's your Richter scale. So let's do it. Y equals 10 to the 9.2 minus 1. What's 9.2 minus 1? 8.2. Sweet? Trying to solve for y. Well, it looks like I'm going to punch that in my calculator. 10 to the 8.2. Big number, right? Put her down. Don't forget comments. That's how powerful it was. So we got this written down. I just don't want to take the time to write that long number down, but that's all right. And yes, you put the 0.2. Part B, write an equation in the form of this for the inverse of that function. Cool? So that goes back to our little 4-step process. Start with this guy. Y equals 10 to the x minus 1. Isn't that the equation they gave us originally? Correct? If we want to write the equation of the inverse, what is the real thing that we got to do to that? Switch what? Switch x and y around. Cool? Now we got to solve for y. Where's y located? Yep. We don't like him up there. This is in exponential form. To bring him down, why don't we just rewrite this in logarithmic form instead? And don't forget, it's log base arg equals exponent. Logs are expensive, correct? So let's start. Log. What's the base in my blue equation? What's the base? 10. What's the argument of x equals my exponent, which is what? Y minus 1. You see how we just kind of made that nicer for ourselves? Now y is no longer in the exponent. We rewrote it as a logarithmic equation. The problem is y is not all by himself, right? So what do we have to do to get y all by himself? Add 1 to both sides. So base 10 of x plus 1 equals y. There There, we're done. And we don't need to switch anything to like f inverse of x or anything like that. They didn't ask us. Just you'll have a y again. Cool. Let's try this bad boy. Give it a read for yourself. So if the pressure equals 0.8 to the x power, where x is how many miles above the earth you are, and they say you're 8 miles above, don't you need to put this in your calculator? Right? And you get a nasty decimal. P is about 0.167, is that right? 167 if you round to 3 decimal places. 168. Label atmospheres. So like if you're on the ground here on Earth, there's normally what they call an atmospheric pressure, right? That's just a pressure of one atmospheric pressure. Well, the higher you go up, you're going to have less pressure, correct? It reduces. That's exponential decay situation. So if you went up 8 miles, there shouldn't be much atmospheric pressure at all. Cool. Write the equation of the inverse. So let's do that. P equals 0.8 to the x is the original equation they gave us, right? We normally switch x and y around. This is a p. Can you handle it as a p, or do you want to change it to a y? Just keep it a p, right? Switch x and p around. So x equals 0.8 to the p. And that's where people have some trouble because they're like, what do you do now? Because you're so trained to solve for y, what do you want to solve for? We want to get p all by itself. Where's p located? He's up in the exponent. So the way to bring him down is to rewrite him as a logarithmic equation instead. Rewrite him as logarithmic. So log, the base is what? 0.8. What's the argument? And that should equal p. Done. Is p all by himself. That's it. Cool. All right.